Okay, next I'm going to demonstrate how to load reference imaging into our histology reconstruction project. So prior to histological sectioning of our sample, we acquired high-resolution MRI at 9.4 Tesla. This is the MRI of our tissue specimen. And I'm going to just open up the image information panel within ITK Snap. I'll draw your attention to the 3D cursor position text boxes. The first row shows the voxel coordinates of our current cursor location. These are coordinates indexed relative to our MRI data. In other words, they're all integer and they begin at 0 or 1. In ITK Snap, they begin at 1. So when I move this cursor around, you can see that the voxel coordinates change. There is a mapping from voxel coordinates to world coordinates that is given in the metadata panel by the S-row matrix parameters. So this is an affine matrix transformation that maps from voxel coordinates, which I call IJK, to world coordinates, which we call XYZ. Now HistoloZee also has world coordinates, which correspond to this third row here, nifty world coordinates, not the ITK world coordinates. They're very similar, except for a negation applied to the first and second parameters. Very important to know this, though. So within HistoloZee, we can make sure that everything is aligned to world coordinates and thus have mappings between our MRI images and our histology slide images. All right, let's create a new project in HistoloZee that has only one slide for simplicity. There's a bit of my code. Make a new project and insert one slide. Okay, again, just as a recap, IJK corresponds to the coordinate system within the slide, with I being horizontal, J being vertical, and K being into and out of the view plane. And XYZ are the current world coordinates. Now let's load up our reference image, that ex vivo MRI image, and you'll notice that two things just happened here. First, a reference image properties panel pops up. This is used for changing the view parameters and transform parameters of our MRI image. And we also get the MRI image. Now, I'm going to just bring this reference image properties window down a little bit and zoom out. Our task here is to align the MRI and histology together. To do so, we have two very handy features. One that lets us translate the reference image in 3 dimensions, and one that lets us rotate the reference image in 3 dimensions. Let's choose the translation tool first, and I'm going to move to the Transform tab. So just very quickly, without explaining what I'm doing first, let's translate this image into and out of the plane. And you'll notice that we have a problem. Our histology was acquired along coronal sections. This is a coronal section of the hippocampus. But the MRI appears in either a sagittal or an axial section. The reason is that we haven't yet specified our slide orientation. Go to the slide menu, select orientation, and either type in the matrix that you want or use one of the standard orientations. Since I know that our histology is acquired along coronal sections, I'm going to just click coronal. Now magically, the MRI image has now flipped to a coronal orientation. But things are still flipped. You'll see that the histology image is flipped with respect to the MRI image. In fact, the MRI image has the correct orientation, and it's the histology image that we have to align now to the MRI image. Before I do that, let me just give you a quick tour of the reference image properties dialog. We can hide or show the image. We can change its opacity. We can, of course, zoom into the MRI image just like with histology images. We can move the cursor coordinates just like in Snap and see things updated in our 3 views. We can even move into and out of the view plane using the right mouse key. We can do the same thing in the slice plane using shift and dragging. There is also an opacity option and a thresholding option. The thresholding option is nice for getting rid of background. This helps us improve alignment between structures that are otherwise obscured by the background. There's also a tint option, which lets us apply colors to the MRI. This is very handy when we have multiple MRIs loaded. For now, I'll just keep it at being a white tint. And we can turn linear interpolation off or on. So again, this is viewing the MRI image with linear interpolation and without. This is actually a very high resolution MRI image. It's 0.2 by 0.2 by 0.2 millimeters isotropic. And we can also put edges on. Again, my particular graphics card has a bug which shows these X's, but most desktop GPUs, graphics cards, don't have this bug. So we can view our MRI using just the edges or in the original format. The Transform tab allows us to view and modify all affine transformation parameters applied to this image, as well as the origin of the image, in other words, the center of transformation of the image. Now, a very handy thing that I like to do is to set the origin to be the location of the current crosshairs. So using this checkbox, we can set the center of transformation to be at the current crosshairs. What this does is allow us to rotate about that current crosshair location and apply all stretches or scales and shears about that crosshair location. And you can set identity. The image can be translated into and out of the plane by holding the right mouse key while dragging, and within the plane with the left button. Similarly, rotations along the K direction or out of the plane, so rotations about the current view axis are done using the right mouse key, and rotations into and out of the plane are done using the left key. And you can see that the image is resampled live on all views, including the orthogonal views. So this applies a tilt to it, etc. Resampling is done on the fly using the graphics card texturing hardware. So if I turn off linear interpolation, you can see that there is in fact resampling happening on the fly here. And you can zoom into this image in whichever plane you choose. Normally we don't see these resampling artifacts because we don't normally view MRI images out of plane like this. The reason you see those artifacts is because I've applied an out-of-plane rotation to the image. Okay, let me zoom out a little bit and show you how we align our MRI with our histology slide. First thing to do is bring the MRI image to a place that you like, and then select your desired histology slide. Now, you'll notice that something just changed here. By clicking the histology slide, what we've done is we've told the crosshairs to go to that location in our 3D world coordinates. So our crosshairs have just changed their K, or slice, coordinates to be at the location of that slide. I can translate the MRI image and rotate the MRI image to match it roughly to the histology slide, and then flip the histology slide to match the MRI image and bring it up using a translation, viewing some of the edges, and applying some rotations. This is a very rough registration, of course. It's just to show you the general principle behind everything. Okay, so now you'll see that on our orthogonal views, we have the MRI image as well as any slices that are currently loaded. I'll zoom in a little bit more just so you appreciate this. If I right-click on the orthogonal view, you'll notice that the MRI image gets updated with that current location. And if I click on any image, the crosshairs immediately jumped to the beginning slide coordinate or K coordinate of that image. So since this image actually has some thickness, moving the crosshairs along the image here doesn't change the histology at all, but it does change the MRI behind it, as you can see. By convention, each slide begins at its topmost coordinate. So by clicking on the slide, the crosshairs goes to the topmost coordinate of the slide, and the MRI again jumps to that location. So I'm going to zoom out of the window here. Besides in-plane transformations, you can also apply out-of-plane slide transformations in the K direction. That is done by right-clicking and moving the mouse up and down. This dark gray line is the origin of our point system. So this is the K equals 0 origin. So again, we can translate into the plane, out of the plane, and within the plane. And if I apply transformations to the MRI, you can see them updated in real time in the reference properties window. We can also type numbers in here. So if I want to apply a 20-degree rotation to the image, I can do that here. And we can apply stretches to the image here, make them isotropic, etc. I'll just fix up this rotation parameter. Okay. Next, I'm going to show you a few basic automatic registration methods to help you align histology and MRI together.